Okay, so we're looking at question 2 on page 56, and then 2D, and then 3C and D. So I'm assuming you got 2A, B, and C. So we'll just kind of capture through that. So yes, the data could be used as by an exponential model because the common ratio is about 1.04 from year to year. Oh, excuse me. I feel like I'm going to sneeze. And then you would put this data in your calculator here, and you would use the exponential regression. And then you should get this equation here. It says based on that regression equation, what's the approximate annual rate to increase the rent? It's 4%. You get that from right there. And it says, assuming the same approximate rate of increase, predict what the Bedlands will pay in 10 years. So in this equation, X is your years and Y is the rent. So basically we're saying that X equals 10, right? Because this is how many years they, for the first 4 years, and we want to know it for the 10. So looking at that, we're going to put that in the equation. So Y is equal to 9595.43, 1.04 to the 10th. So I'm going to just put that in my calculator, but I'm going to do the 1.04 to the 10th first. And then I'm going to times it by, oh, you don't even want to know what I did. Because I'm like, that doesn't make sense. So I get 9595.43 times 1.4802. And I'm going to keep all the decimals when I do my multiplying, but it continues. So I get this 1.4802. So times 9595.43. And I get 14,203. And it says to the nearest dollar, so that would be our solution. So I don't know where they must not have rounded their equation. When you do the regression, I didn't actually do the regression, I just took this off of the answer key. So I'm going to double check that. It might be an error. If we do that actual regression, if this is what you're getting, then you're okay. You're using that equation to get it. But I have a feeling that when you do the regression, you get a slightly different decimal, maybe one a little like 1.039 something. So I can double check that. But if this is what you've done, it could just be an error in the answer key, or that they've rounded it, right? So keep that in mind. But that might be what's going on there, okay? But that's what you would do. You would put in 10 for X and get your value for Y. So on number 3, Jared and his grandfather Guido recorded the length and mass of every rainbow trout they caught. So you do a regression with this data, put that in, graph on the calculator. You should get a regression equation similar to this. Y is equal to 19.528 times 1.009 to the X. And it says, caught a fish that measured 400 millimeters. So that's the length, which is our X, and our mass is our Y. So use your graph to estimate the mass. So when you have that in your graph, 19.528 times 1.009 to the X, and you graph that. I'm just looking at my data. My windows are not good, so give me a second here while I change my windows, because our windows should be dealing with this data, right? So X ranges from 259 all the way up to the biggest one is 392. So I'm going to make X go from 100 to 400, and my Y goes from, it goes up to 622, and I'm going to go from 0 to 650, and I'm going to graph that. And we want a fish that measured 400 millimeters, so I'm graphing that. So this is our X value, right? X equals 400, not 440. So when I put that in for my value, second function trace value 400, and then I get Y equals 703. It's an estimate. So again, I didn't do the actual regression, so the regression probably has a little more decimal places than this one does. And I can check that out for you. And they're probably using all the decimal places. And that's probably why the next one's going to be a little bit off too. So Jared's father would like to catch a fish with a mass of 1,000 grams. So he wants Y to equal 1,000. So we're going to have to extend our windows again. Y has to go up to 1,000. So I'm going to guess that my X is, I'm going to put it at 500. And we're going to graph that. And then we're going to make Y equals 1,000. Okay, Y equal 1,000. So it's all about changing those windows. And we're graphing that. And then we'll do an intersection. Right? And I bet I'm going to be off again too because I didn't do these regressions myself. Yeah, because here it says X equals 439 millimeters. So I think if I do the actual regression, I'm going to get the correct values. And don't round, like when you put the equation into the Y value, don't round.